Hi, see you again here in our class Fundamental of HVAC. Now we are coming to week's 8 in our course. The topic we will cover about the evaporators. So today we will discuss in depth about the evaporators. Okay, guys. What is the evaporator itself? We can say the evaporator is a heat transfer system in and is that part of the refrigeration cycle in which liquid refrigerant is evaporated for the purpose of removing heat from the refrigerated space or product. So actually the concept or principal concept of evaporator is equal in with the uh, another part in HVAC that we call condensate, but it's like a reverse system from the condensate system. Now we just utilize the steam part, then the cool part will go to the room, the conditioning system, while the steam or hot part we will take into the cooling system. It's mean will the cooling back into the uh, what we call uh, pump system, right? Yeah, correct. So, responsible for absorbing heat into the refrigeration system, we will utilize the heat into refrigerant system. Then we just recycle back the heat system into the cooling system. Uh, while the refrigeration release the cooling temperature into the room, the conditioning for the room conditioning. So after that, uh, the evaporator is maintained at temperature that is lower than the medium being cooled. And then the capacity of any evaporator or cooling coil is the rate at which heat will pass through the evaporator walls from the refrigerated space to the vaporizing liquid. Then remove for both latent and sensible heat from the air in the refrigerated box. So latent heat is itself is in the form of moisture, and then sensible heat reduce air and product the temperature. Okay, we have a several type of evaporator here. Based on the construction, the various evaporator can be spread. The first one is the bar tube evaporator. What is the bar tube evaporator is? The bar tube evaporator are made up of copper tubing or steel pipes. Then the copper tubing is used for small evaporator where the refrigerant other than ammonia is used. The steel pipes are used with the large evaporator where ammonia is used as the refrigerant. Yeah, this in this case if ammonia. And then in the bullet D, the atmospheric air flows over the bar tube evaporator and the chilled and leaving it used for the cooling purpose. Then the bar tube evaporator are usually used for liquid chilling. Okay, this considered under the bar tube evaporator. And then the second one is very familiar with in the HVAC system. That one is we call plate type of evaporator. The coil, usually made up of copper or aluminium, is embedded in the plate so to form a flat looking surface. Okay, you can see in the figure. Then the plate type of evaporator looks like a single plate, but inside it there are several turns of the metal tubing through which the refrigerant flow. Then an advantage of the plate type of evaporator is that they are more rigid, as the external plate provides lots of safety. Okay. Then this type of evaporator is widely used in domestic refrigeration. The plate can also be welded together, forming the bank of the plate. Type of the evaporator can be used the larger evaporator of higher capacities. Okay, so the construction of the evaporator you can see in the figure. So layer by layer. So every layer considered a split of our evaporator. So the liquid will flow through every single plate. This one is a very common use in the hatchback. This one very familiar with the hatchback system. You can see the this evaporator every commercial air conditioning that sold in the market, right? We call the fin nut evaporator. So because this system will employ the fin in the tube to cooling system. So we try to study about the fin evaporator system. The first one are the bar tube type of evaporator covered by the fins, and then fluid tend to move between the open space of the tube and doesn't come in contact with the surface of the coil. Use the bar tube operator are less effective, okay, because without the contact between them. And then the fin evaporators are more effective than the bar tube evaporator. Yes, because maybe fully contact between the tube and fin are most commonly used in the air conditioner of almost all type, like windows, split, package, and the central air conditioning system. We will use this type. And then the last one is shell and tube types of evaporators are used in the large refrigeration and central air conditioning system, comprise a large number of tubes that are inserted inside the drum or the shell. Depending on the direction of the flow of the refrigerant in the shell and tube type of evaporators, they are classified into two types: dry expansion type and the flooded type of evaporator. Okay, we can see what the meaning the dry expansion evaporator itself. In the dry expansion evaporator, the refrigerant flow along the tube side and the fluid to be chilled flow along the shell side. And the second one, the flooded evaporator. In case of the flooded type of evaporator, the refrigerant flow along the shell side and fluid to be chilled flow along the tube. Okay, different about the dry and flooded. So this one is using disparate by the dry one in the tube side and then the outside the tube. So the fluid will chill flow along the shell side, so the outside of the tube. So this one is flooded type evaporator refrigerant along the shell. So along the shell. So same like the type when we discuss about the condenser system, right? Okay, this one the shell type. So as we know, inside of the shell is the tube, so the tube will cover by the shell. So the fluid as liquid to coolant the tube will suck in from the lower from the bottom side, and then will supply to outside as coolant to the upper side. Okay, so the coolant will go through the upward, correct? And then the refrigerant, or maybe refrigerant from using the water, will go inside here, and so will flow like this until the finish line. Okay, this side from the cross area you can see much of the tube here, and then the coolant will go through between the tube is here. Okay, this one the shell shape. Okay, the system like this, same like the condenser system. Okay, shell and coil evaporator. Shell and coil evaporator have one or more spiral-shaped bar tube coil enclosed in welded steel shell. They are generally dry expansion type with refrigerant in coils and chilled liquid in the shell. Okay, they have thermal capacity for application for high bar frequent loads. They are used for chilling of drinking water and other aspects where the cleanliness is a factor. For example, bakeries and photographic laboratory, and so on. These are the application. According to the mode of heat transfer, natural convection evaporator are often used in the application where low speed are desirable or damage dehydration product possible. And then the greater the temperature difference will produce higher rates of air circulation, because the difference between the density of warm and cold air increases. And then cold air is denser than warm air. Therefore, the natural circulation evaporator usually mounted high above the floor dye-refrigerated cabinet. So the concept, this one is we will apply heat transfer law. Heat transfer law is using our heat transfer coefficient U. In this case, U is not internal energy, but U in this case is heat transfer coefficient. So the concept is same. We will apply conductivity, thermal, and also with the enthalpy, right? So how to calculate? You can see, we can check here. So this one is we can consider as fin. Or I think this one better we consider as the wall of tube. So inside is T1 considered as inside of tube, and then T2 we consider as outside of tube. So how the law of heat transfer formula is from the concept heat transfer, whereas the U is the thermal coefficient. We can calculate by super H1 plus delta X per K. K is conductivity, thermal conductivity, and plus H super H2. H2 is condition outside of the piping system. H1 is inside of tube system. This one outside of tube system. So we consider by calculation the resistant flow. system flow, we can describe the condition is like this. This one is the inside of tube, this one wall of tube, and then outside of tube. Okay, how to calculate the coefficient thermal? You can use this formula from this illustration. Then we can calculate also the flow rate, thermal flow rate, by Q dot. Q dot is mean by time. So how many energy can transfer during time, during the time, every second. So the formula is coefficient thermal time to A time to delta T overall. So delta T here, and then just put the area here, so we can see the area here already. Here we don't have area. Okay, so we just put here. So now we can calculate the thermal flow rate. Okay. Now we go to forced convection evaporator. So high velocity air over the closely fin coil can increase heat transfer. Yes, correct. So we can add more fin coil inside of around the tube. The use of forced draft can reduce the overall size and weight of the evaporator, which can reduce purchasing and installation costs. Yes, correct. Forced draft also give more rapid cooling, even temperature, good humidity control, easy defrosting. So the fins on the forced draft evaporator are very closely spaced, which give a high capacity rating. Okay, this one how the fin evaporator work concept. So this one the fin, the silver color, and then the yellow or orange. This one orange, I think. This one red because it's so hot, and then the liquid will supply from the input here, and then outside of the liquid or refrigerant will go through this tube. So inside of evaporator will look like the spiral shape, and then we can use the natural draft, or we can use the force air. Okay, that's all today for our class in the evaporator system, and see you again in another class. Okay.